guys, very happy morning to all of you. So now we will have a revision of the fluid mechanics. Okay, so mostly within 3 videos or 2 videos I just try to cover the entire fluid mechanics. Okay, so without wasting time, let's get started. Okay, so fluid mechanics, I think so you don't know, it means a solid means shear stress is directly proportional to shear stress. So guys, this is only, it's like a revision. Okay, so quickly we will just cover each and everything. Okay, so tau directly proportional to d theta, and you can see in liquid shear stress directly proportional to deformation rate. Okay, d theta by dt or dq by dy. Okay, so you are extending density equal to mass by volume ml minus. Okay, density equal to kg per meter cube. Okay, suppose whenever the temperature increases or decreases, see whenever the temperature increases, water expands. Okay, little bit, it means how to say, means okay, I mean as the videos goes on, I'll just okay. So generally whenever temperature increases, volume expands. Okay, at the time density tends to decrease. Okay, so if the temperature, if the pressure also increases, the volume decreases, at the time density increases. Okay, density generally represents heaviness of the fluid, and specific volume means this one is specific volume equal to volume divided by mass equal to rho equal to 1 by r specific volume. Okay, so specific weight equal to weight divided by volume. Okay, you can see specific weight is Newton per meter cube. Okay, so per 1 meter cube how much amount of force it gives us. Okay, that's it. Okay, this is called a specific weight. Okay, so this one unit is m l power minus 2 t power minus 2. So this one that much not necessarily needed, but change this in means Newton to, it means mass into gravity for the certain value. Like that you can just go on. Okay, so next one, if specific weight, or suppose you can also write specific weight equal to density of gravity. Okay, specific weight can be written as it means density of gravity. This is also important formula. So depending on the temperature increase or decrease, this also will change. Okay, I think so, got the point. So specific weight equal to, sorry, specific gravity equal to density of the fluid divided by density of the standard fluid. Okay, then specific gravity is equal to density of the fluid divided by density of standard fluid. Standard fluid is water. Okay, relative density is density of two different. Okay, so this one is greater than 1, this one is greater than 1. So next one, cohesion and force of attraction of small same molecules. Okay, enables fluid to resist tensile load, and addition means different molecule attacks to enable to stick. Okay, so liquid generally the cohesion is so much higher because same molecule attacks. Whenever you just heat the liquid, what will happen? The cohesion start to decrease. But the same thing whenever for the gases, whenever you just, it means heat the gases, generally the cohesion start to increase for the gases. Okay, then it means for normal thing the gases are so much lesser, but whenever you increase the cohesion is so much higher for the this one. Okay, I think so you got the point. Okay, so next one you can see this one. Okay, ideal fluid means imaginary girlfriend. It means imaginary, definitely we won't get any kind of girlfriend like Samantha, Aishwarya, any kind of it means Hansika. So imaginary will just make that we have an ideal girlfriend. Like that ideal fluid is imaginary fluid, incompressible, zero cohesion, zero viscosity, but each and everything will be okay. Sometimes mostly it will be incompressible, the zero cohesion won't be. So zero viscosity, it can't, it's not possible. Okay, so viscosity generally exists for each and everything. Okay, so it is ideal fluid. So viscosity is internal resistance offered by one to adjust to the next. So due to cohesion only the viscosity generally occurs. Okay, what is cohesion? Cohesion is attraction of two different molecules, sorry, two same molecules. Okay, so simple Carty flow is dou p by dou x equal to 0 and property is linear. Okay, so shear stress equal to u, it is viscosity of d upon dy. Okay, this entire thing I think so around. So for shear force equal to into area, so area where the liquid surface touches the surface. Okay, thermal energy means it means for a certain time the velocity will be, it means keep on increasing, but after a certain amount of time the velocity will be constant. That's it. Okay, so you can see in this the bottom area we need to consider, and shear force equal to this one. Okay, so this one you can see, just make sure the unit is same. Okay, so density of air is 1.2 kg per meter cube. Okay, so density of water is 1000 kg per meter cube. Density of mercury is 13 tons. Okay, 13580 kg per meter cube, and density of oil is this one. Okay, 800. So and generally you can see viscosity, it means viscosity of oil is how much? 375. So that's why it means the viscosity of since the viscosity is so much higher, so this is for oil. Okay, I think so. So this one I think so. So the weight of will go down. So you can see this one weight will be like this. Okay, so generally according to this sector you can see weight is W of cos theta, and this one is W of sin theta. Okay, So it's W of cos theta, and generally the normal direction will be, okay, that will say in the, it means engineering mechanics. So you can see Fs, it means shear force this side, and W of sin theta, just make sure equal, and weight is about this one, we'll just make it in theta. Okay, so horizontal is by theta equal to 0, velocity equal to 0, this one I think so generally it's a basic thing. Okay, you can see we are acting the velocity, it means in this direction. Okay, so the velocity acts in this direction, means you can see the force, and you can see the force also we are just applying here. So the entire thing tends to go this side. Okay, F plus W sin theta equal to F of S. Okay, entire thing like this. Okay, I think so I got the point. So generally a simple thing, I think so I got the point. So thin plate moving in a horizontal gap, you can see it is a thin plate, and the force here we are applying here, and you can see it means the shear force and this one applying in this direction. Okay, so this thing, okay, just make sure it is equal. So definitely both will have same shear force. Okay, and you can put here, and for location of a maximum shear force is this one, yt of yp equal to root of nu t of nu v. Okay, that's it. So this word it was okay, I think you got the word. So next thing you can see now, see guys, whenever you just take like this, so you can see it is how to say, means it's not traveling in a horizontal way, it's going in a vertical direction. Okay, so anyways from the bottom definitely the weight will just push upwards. Okay, that is called as buoyancy force. So buoyancy force plus force equal to shear force this one, then shear force this one. Why two side is considered, means because both sides also the liquid is there, so that's why we consider the both of the liquid. Okay, into plus of weight will act on us. Okay, so tau equal to nu du upon dy, and if shear, it means viscosity increases, this du upon dy slope definitely will have decrease. Okay, I think so variable. So this word is simple thing. So why? So we will write a different format. V equal to radius into velocity. Okay, you can see this is a cylinder. Okay, radius into velocity. So radius is d by 2 of velocity. It means r into omega. Okay. So omega what you can 2 pi n divided by 60. If it is given in minute or seconds or meter, that's your wish. Okay. Force equal to shear stress into area. So you can see area is the entire cylinder area 2 pi r into L. Okay. So power is torque into omega, and power is force into velocity. We can, that's our ratio. Okay. So next one you can see viscosity. As I just told, viscosity is directly proportional to root of temperature. Okay. Viscosity is directly proportional to root of temperature. You can see generally whenever temperature increases, the liquid viscosity start to increase, but you can see gas viscosity start to increase. Okay. Generally viscosity of liquid is greater than always viscosity of gases. Okay. So this one I think so you can easily do it. Okay. Not a bigger case scenario. Okay. So next one you can see what is the unit of viscosity. It is Pascal second. Okay, Pascal second, Newton per meter square dot second. Okay, Pascal it means second. So 1 poise is, so this also subject is quite important. So what is 1 poise? 1 by 10 Pascal second. Okay, 1 poise is 1 by 10 Pascal second. Okay, so next one you can see, so this is other things. Okay, so generally for liquid it means viscosity directly proportional exponential of b by t. Okay, so we can just put constant and we can just make it. Okay, you can see viscosity sometimes vary exponentially. Okay, so next one kinematic viscosity. Kinematic viscosity is nu equal to viscosity density by density. Okay, so first one comes to viscous effect and inertial effect. Okay, both of the effect come. So what is one stroke value? One stroke equal to 10 power minus 4 meter square of second. Okay, meter square per second. Okay, I think so. So 1 poise is Pascal second. Okay, Pascal second means it means 1 poise is 1 by 10 Pascal second. So Pascal is meter square of second. Okay, so after that you can just change according to our wish. Okay, or kg per meter per second also you can say it's our wish. Okay, whenever temperature increases, density decreases, and viscosity also start to decrease. Okay, this is a normal thing, and this one for gas is quite different. So kinematic viscosity is different. Kinematic viscosity directly proportional temperature 3 by 2. Okay, temperature of 3 by 2, but the dynamic viscosity temperature of 1 by 2. Okay, so you can see here the kinematic viscosity with the pressure is no use. Okay, kinematic viscosity is comes under the category of stroke. Okay, dynamic viscosity comes under the category of pi. This is the most important. Kinematic viscosity comes under the category of which one? Stroke. But the dynamic viscosity comes under the category of poise. Okay, I think so got the point. Okay, so you can see Pascal second equal to kg per meter square. This is the same thing. So circular disc, this one I just already explained. So in this the velocity itself will be vary. Okay, here it will be 0 velocity, but you can see here the maximum velocity is. So we, depending on each and everything, it will differ. Okay, so shear force equal to this one. Okay, suppose if I want higher time means I will explain here, and here the torque also will little bit vary. Okay, since it depends on the outer radius, so outer will be maximum torque. Okay, 2 pi nu w r cube of 3y. Okay, so this thing it means while I'll just also explain the problems at the time I'll just tell. So in this the same thing will be, but divided by sin theta value. Okay, that's it. Okay, so whenever the shear force of top and bottom is same, like this we will just put, and means d top of du upon dy of top. Okay, like this we will just put. Okay, so next one, classification of fluid. So you can see this one. So Newtonian fluid obeys Newton's law of viscosity, tau directly proportional d theta of dt. Okay, tau equal to nu du upon dy. So nu is constant. Okay, you can see this is rho. So tau equal to nu upon dy. So whenever it means sometimes a non-Newtonian fluid also there, that generally obeys Oswald's d Gauss law. Okay, so for that tau equal to a plus of v du upon dy power of n. Okay, so for this we will just write in a different way. Okay, so you can see in this tau equal to a plus of mu apparent of du upon dy. Okay, generally mu apparent will be written as du upon dy n minus 1. Okay, p times mu apparent equal to constant b du upon dy n minus of 1. Okay, I think so, got the point. So generally you can see this is the equation is important. Okay, so what is the one thing? So it is dilated, next one is pseudoplastic and Bingham, next one is rheopatic, and next one is thixotropic. Okay, so in this you can see, guys, so here how to see means here a equal to 0 for the Bingham, for dilated and pseudoplastic a equal to 0, but you can see this n greater than 1, but for this n less than 1. Okay, this is it means for Bingham plastic n equal to 1, but a will exist. Okay, a greater than 0. So for this the above three categories above present, a greater than 0 only. So for this is rheotropics, n greater than 1, for thixotropic n less than 1. Okay, so you can see the slope is increase but decrease, but the down slope always increases. Okay, as I just already explained to you. Okay, no need to confuse. So dilatant is shear thickening fluid, shear thinning fluid. Okay, wait, shear thickening, yes, shear thickening. Okay, shear thinning is pseudoplastic, yes, that's what I was thinking. Okay, dilatant is shear thickening fluid, and you can see tau equal to mu apparent of du upon dy. Okay, so what is it means formula? You can see this one is tau du upon dy, this one is it means this one is mu apparent. Okay, so mu apparent is what? B du upon dy n minus of 1. Okay, I think so, all the logic. Okay, so mu apparent du upon dy, this one. Okay, so you can see for this a is 0. Okay, a is 0, just put here mu apparent du upon dy. So mu apparent equal to this one. Okay, I think so, got the point. So okay, so next one is shear thinning fluid. You can see later it means it start to decrease. Okay, whenever you just increase the velocity, you can see the mu apparent start to decrease. Okay, mu apparent means the entire thing will just decrease, because you can see the other thing is it means n less than 1. Okay, n is less than 1 means this entire thing will come negative. Okay, so that's why it started to decrease. Okay, simple logic, just use the common sense. So here the viscosity decreases with the deformation rate. Okay, so shear thinning effect very strong in plastic, blood, milk, ketchup, and if thinning effect is so strong, it is plastic. So that's it. Okay, basic thing only, guys. So next one is Bingham plastic fluid. Okay, tau equal to a equal plus of mu upon d upon dy. So you can see this a is constant. So you can see here the entire thing, it means n equal to 1. So n equal to 1 means here the n equal to 1 means it is 1 or 0. So mu apparent generally it means in this thing what you will just tell. Say as you can understand. So mu apparent will be just, it means since du upon dy is generally 0, so generally it become a constant. Okay, it means constant means it becomes a normal slope. Okay, I think so you can understand. Okay, So this entire line will become constant, okay? And you can see it is ideal plastic way to paste solid, because until this way it will be a solid, and after it will become a normal thing, okay? Become plastic plate, okay? So next one is rheopatic. So rheopatic is tau equal to a plus of mu upon d upon dy, okay? You can see in this one, the mu upon cv d upon dy, it means as n is greater than 1, so it means this entire thing will be positive, okay? I can see. Okay. So you can see this n is greater than 1, this will be positive. So the new operand will be also positive, okay? Since d upon dy increases, mu upon also increases. So mu operand increases with the time. With rheopatic and thixotropic depends on time, okay? Shear load gradually increases to maintain constant shear strain rate, okay? By picking motor, as time increases mu operand, and if you left, it becomes a solid, and okay. So next one, thixotropic, you can see whenever d upon dy increases, the mu operand decreases because n less than 1, so it becomes negative. This entire equation becomes negative, okay? So mu operand decreases with time, decrease of shear load to maintain constant strain rate, okay? So example lipstick. So apply first hand, it means first hand, okay? So next you can see this is dilated, neodymium, pseudoplastic, bingham, rheopatic, bingham, and thixotropic, okay? So you can see this one, new operand equal to this one time. So it means here we don't consider d upon dy. You can see the line, because thixotropic, rheopatic, linear line is to be, okay? So ideal for LCD, imaginary, incompressible, zero cohesion and zero viscosity. So this entire thing is ideal fluid, okay? I think so, understand. So ideal solid means you can see this one, okay? Next you can see compressibility, okay? Compressibility B equal to how will dV upon V divided by dP, okay? It means compressibility means by changing in pressure, how much the change in volume with respect to original volume is been occurring, okay? That's it. So compressibility and bulk modulus is little bit inverse, okay? So in this thing, by changing in volume, how much is the pressure difference we are just maintaining, okay? We are just saying that is called as bulk modulus, okay? It means while it's been given like this, with compressibility, the bottom factor is need to be considered. So you can see this is dB, okay? And zoom a little bit. Okay, you can see this is dP, okay? This is the differentiation of pressure. While the pressure changes, how much the ability of volume, it means that is, okay? Bulk modulus K equal to this one dP divided by minus of dV upon V, okay? So it means change in volume with respect to the original volume equal to d density of density, okay? So generally compressibility will be 1 by bulk modulus, okay? For incompressible fluid, bulk modulus, it means bulk modulus is 0, and the compressibility, it means the compressibility will be 0 and the bulk modulus will be infinite, okay? So 1 by 0 tends to be infinite, okay? That's it. So pressure equal to 1 by of P, okay? And this one absolute pressure, you don't know. So isothermal compressibility is generally greater than isotropic compressibility, okay? So next one is surface tension. So surface tension behaves as stretched membrane under tension, definitely. So the tensile force tends to be surface tension force, and the surface tension equal to, it means surface tension equal to surface tension force divided by length, okay? So Newton per meter, and next one will be, so Newton can be written as joule per meter also, okay? So it may be written in joule per meter square, okay? So what is the unit of joule? Joule can be written as Newton per meter, okay? So Newton is a joule per meter, okay? Joule per meter square, okay? So this one I think so you know, unbalanced cohesion having, it means surface tension, okay? So zero surface tension means ideal fluid, zero cohesion, and each and everything. So and generally critical point of water. So no liquid and vapor at the time, the each and everything will be there, okay? So I think so you can understand, okay? So temperature increases, cohesion generally decreases, and sigma also decreases, okay? So it means next one you can see for liquid droplets, gauge pressure liquid droplets is 4 sigma upon d, and next one for soap bubble you can see 8 sigma upon d, and liquid jet you can see 2 sigma upon d, okay? Bursting force equal to joining force, okay? So next one work done equal to surface tension into change of area, okay? So So surface tension equal to, it means energy divided by upon area. Okay, area is 1 meter square. So increase in surface energy equal to W. Okay, change of surface energy equal to W. Okay, W equals this one. Okay, just a normal thing. Okay, don't need to just confuse yourself. So the next thing you can see, raindrop is spherical. Okay, raindrop spherical and minimum energy stage. Okay, yes, definitely. So large spherical droplet and small number of period converting is W equal to sigma 4 pi r square n 1 by 3 minus of 1. Okay, so next thing you can see wetting liquid and non-wetting liquid. So wetting liquid generally addition is greater than cohesion. So non-wetting liquid cohesion is greater than addition. Okay, theta less than 90 and this one theta greater than 90. So next one, capillarity of liquid. So capillarity equal to H equal to 4 sigma cos theta divided by rho g d. Okay, 4 sigma cos theta divided by rho g d. So generally H is directly proportional to diameter of this capillarity. Okay, so here the addition will be always greater than the quotient. So just a simple thing, the surface tension force lagged upwards, but the water, it means weight of the water acts downwards. So make sure it is equal and we will get the answer. So for this one, when it is parallel with 2 sigma cos theta by rho g d. Okay, so if it is like this, means you can see 4 sigma cos theta divided by rho g, means d minus d. Okay, so generally non-wetting liquid will have like this. Okay, downwards. Okay, I think so you can understand. So capillary rise takes place where the capillary rise, where addition is greater than quotient. F of st cos theta equal to weight of fluid, both balance and capillary rise stops. Okay, capillary falls, generally quotient is greater than addition. So you can see vertically upward, it means generally for mercury this kind of thing. Okay, so for the capillary fall is minus 4 sigma cos theta divided by rho g d. Okay, so we can just go to the next thing. So you can see, so next one is flow around submerged bodies. Okay, because I just told about the flow around submerged body in the before thing. You can see drag force and lift force. So force exerted by the fluid in flow direction, and lift force is about the tendency to lift. Okay, so drag force is cd 1 by 2 rho v square of a. Okay, so this is coefficient of drag, and FL equal to CL into 1 by 2 rho v square upon a. Okay, this one is CL is coefficient of lift. Okay, so area A is projected area, so this small thing is projected area. Okay, so resultant is root of FD square plus of FL square. Okay, so it means you can see FD equal to, it means drag force equal to weight minus of buoyancy force. Okay, weight minus of buoyancy force. Okay, so drag power, it means drag power equal to FD into velocity. Okay, power is force, it means force in velocity. Just take. Okay, so power is force into velocity, so drag force is CD 1 by 2 rho v square into a, this is extra velocity. So power is directly proportional to velocity power cube. Okay, next one is Stokes law. Stokes law is CD equal to 24 divided by Reynolds number. Okay, this is also important. So Stokes law equal to 24 upon Reynolds number. This is sphere. Okay, so Reynolds number generally less than 0.2. So FT equal to, it means this normal things. Reynolds number, I think so, rho VD upon nu, that's it. Or rho VL upon D, rho VL upon nu. Okay, or rho VD upon nu also we can write. Okay, so FD is CD into 1 by 2 rho AB square. Okay, so generally CD is 24 upon Reynolds number, just put here. Okay, and it means rho VD upon nu, each and everything. And area, it means it depends upon area. Okay, it means the projected area only we need to take pi by 4 d square. It means it depends on circle, or it depends on each and everything. It's our issue. Okay, projected area we are taking, and drag force is 3 pi, I think so you can understand, 3 pi nu dv. Okay, so next one, skin friction drag is 2 by 3. Okay, so pressure drag is 1 by 3. Okay, that's it. Just a basic thing, guys, don't need to confuse yourself. So next one, Magnus effect. You can see the phenomenon of producing lift by rotating of a solid body. So you can see while it's been rotating, generally the bottom will be low pressure. Okay, so the top will be, so the bottom will be higher pressure, because the velocity here will be so much lesser. Okay, and in the top portion the velocity will be so much higher, the pressure will be less. Okay, so that's why it has a tendency to rotate. Okay, So that's it. Next one you can see streamline of bluff bodies. If it means conscious effect is made upon to align its shape with the anticipated streamliness flow. Okay, it is much easier to flow in a streamlined body through a fluid. Okay, example fishes. Okay, it's a normal thing. Okay, this is shear stress and this one. It means whenever you keep like this, that generally the shear stress will be there. But whenever you keep like this, it means in a vertical way, the pressure will be so much high, but the shear stress won't be there. Okay, just a normal thing. Okay, so terminology you can see first. It means first the body moves. This one as I just told about you. Okay. This one okay. Drag is shear stress drag due to friction effect, pressure drag due to shape. Okay. So C equals the coefficient of drag plus the coefficient of drag upon pressure. This one friction and this one okay. So boundary layer theory I also told to you. And generally you can see real flow is boundary layer theory happens, for ideal flow no boundary layer. So tau equal to nu d upon dy. Okay. Okay, so Reynolds number to rho u of x of nu. Okay, so here each and every location we need to find. Okay, so Reynolds number at x of it is okay. So what I just told about stroke equal to 10 power minus 4 meter square per second. Okay, so velocity here entire thing in the fluid mechanics, entire thing we will take average velocity. Okay, so Reynolds number equal to inertia divided by viscous. So for laminar flow what will be the so much higher? For laminar flow it is be layer by layer fluid, so there the viscous will be so much higher. So for turbulent flow inertia will be so much. So for Reynolds number the turbulence flow will be so much higher, but for laminar flow the viscous the Reynolds number will be lesser. Okay, so next one equal to displacement thickness. Displacement thickness equal to 0 to it means displacement thickness of 1 minus of u upon capital U upon dy. Okay, so this u upon this one v, it means this thing idea, it means while the question has been explained, I'll just explain to you. So next one, displacement thickness is generally used for mass balance equation, rho a b. Okay, so next one, momentum thickness is, it means u upon capital U 1 minus of small u upon capital U of dy. Okay, this is displacement thickness, this is momentum thickness. What it is being used is momentum balance. So next one, energy thickness is this entire thing will write and 1 minus u upon capital U the whole square. Okay, energy thickness, this is for kinetic energy balance. Okay, so 1 by 2 density means rho a v cube. Okay, that's it. Okay, that's it. So generally you can see it means whenever the 10 comes here, 6 goes here and 4 goes out. So that 4 also should not go out, so that way we just make the sure the bottom will have a certain kind of displacement. Okay, certain kind of displacement thickness. So m dot c equal to m dot f equal to 0 to sigma rho d upon into 1. Okay, this entire thing. I think so. Can just a simple thing only. Okay, so by delta star we can find the mass flow rate. Okay, so delta star you can find the mass flow rate at the top. Okay, simple thing. Okay, m dot equal to density into delta star into 1 upon u. Okay, this one thing. So boundary layer mass flow, just a simple equation guys. Okay, so delta star equal to 0.99 of u. Okay, so S equal, generally this is a most important thing. So S is displacement thickness is normal into mass balance equation. Next one is momentum balance. Next one is kinetic energy balance. Okay, generally the most of the question will be asking u upon u, y upon like that. So integration we should do correctly. And next one is shape factor. Shape factor is displacement thickness divided by momentum thickness. Okay, this entire thing. Okay, so I think so you can easily calculate this one. So just integration so much important in your mind. U upon capital U, y upon delta equal to 1 by n. Okay, so delta upon 1 by n plus 1. So this entire thing. Okay, okay. So next is this also little bit important. So not just don't confuse. So here the laminar flow is equal to S 0.5, and for translation x 1.5, and for turbulent x is 0.8. Okay, but for frictional you can see F directly proportional x power minus 0.5, and this one x directly proportional x power 0.5, and this one will decrease F directly proportional x power minus 0.2. Okay, next one is one carbon momentum integral equation, all valid, and the tau equal to rho u square dou u upon dou x. Okay, rho u square dou theta of dou x. Okay, C f of x equal to tau naught 1 by 2 rho u square. Okay, so average coefficient of drag is CD equal to FD 1 by 2 rho. This one I just already explained to you. Okay, so okay, so you can see for integration which take means 1 by L 0 to L, it means per each and every location. Okay, see f of x of dx, it means each and every location you are just taking. Okay, so drag coefficient, it means drag is mass into area, sorry, mass into acceleration. M dot, it means of change of velocity. Okay, this one m dot will be rho into q of velocity. So this one suppose density, this one means discharge, you can write du upon w into v upon v. Okay, so density dy upon u into u square. Okay, this is maintained momentum. So next one, if it is drag forces density. So guys, whenever you are just seeing the problems, we will have a clear cut understanding. Okay, it means after this also, means while we are just doing the previous year question, I will explain each and everything once again. Okay, so theta into 1 of u square. Okay, this entire thing. So next one, one carbon equation, tau naught rho u square rho theta of dou x. Okay, so generally you can see y equal to 0 and so y equal to 0, nu, it means u equal to 0 also. So no place, no slip condition. And if y equal to delta, u equal to q. Okay, this is a basic condition. Okay, so y equal to 0, dou square u upon dou y square equal to 0, and dou y equal to delta, this one. Okay, this is generally for Prandtl. And you can see Blassi's equation. So Blassi's equation is third order non-linear ordinary differential equation. Okay, non-linear. F triple dash, okay, f triple dash 1 by 2 f of f double dash equal to the third order non-linear ordinary differential equation. Okay, so you can see delta, it means what is the, it means this one is equal to 5x divided by root of rex. Okay, so change of this one is equal to delta by root of x. Okay, so coefficient of friction equal to 0.664 divided by root of Reynolds number. So delta directly proportional to root of x. Okay, so next one, it means coefficient of drag is equal to 1.328 divided by root of Reynolds number of L. Okay, ft equal to 1 by 2 rho a u square. So this one equal to 1 by root of x. That's it. So basic thing only, guys, don't need to confuse. Okay, fluid mixes slowly due to the viscous diffusion, and however the large radius in the turbulent flow almost much more rapid and through mixing. So next one, turbulent moving layer, they are thick and in the turbulent moving layer also little bit of laminar sublayer will be. So turbulent moving layer follows logarithmic law over 1 by 7th of power law. Okay, so u upon capital equal to y upon delta 1 by f sub 7. Okay, so here the laminar sublayer will be, so laminar sublayer equal to 11.6 of u divided by rho of tau naught of rho. Okay, 11.6 of u divided by u, friction velocity. Okay, so displacement is the x power 4 by f 5. Okay, that's it. So, okay, so we will just cover the extra chapters in the later on video. So that's it for this today video, and thank you.